All right, so this one we have these two nodes. We have to find VO. So let's set up our ground node. This will be 0 volts. The directions of current: I1, I2, I3, and let's call this I4. So let's call this V1 and let's call this V2. For node V1, it's I1 plus I2 plus I4. Node V2, it's I4 plus I4 plus 3 amps equals I3. And now let's write an equation to represent these I values. So I1, it goes from high potential to a low potential. So V1 minus 30 all over 1. I2, it'll be V1 minus 0 all over 2. I3, it'll be V2 minus 0 all over 16. And then I4 is where it becomes tricky. Let's say this point is VA. So I4 will be high potential V1 minus low potential VA all over 4. Now we have to find a way to represent VA. So as current keeps moving to the right, VA drops by 2 VO because it leaves from the negative terminal. And this is what V2 will be equal to. So VA equals V2 plus 2 VO. Alright, so we can plug that into here. V2 plus 2 VO. Now we have to find a way to substitute VO now. So we know that looking here, we know VO is equal to 2 I2, okay? Positive I2 as I2 moves downwards, so it hits the positive terminal first. So VO equals 2 I2. Now, now look at this. So we have this equation here. I2 equals V1 all over 2. Let's times both sides by 2. So 2 I2 equals V1. So that means VO is equal to V1. So we're going to replace VO with V1 here. Now let's distribute the negative. So it'll be negative V2, negative 2 V1. And now we can solve. So I1, it's V1 minus 30 plus I2, V1 all over 2 plus I4. So it's V1 minus V2 minus 2 V1 all over 4. Now second equation, I4, V1 minus V2 minus 2 V1 all over 4 plus 3 equals I3. I3 is V2 all over 16. Now let's simplify our first node. So V1 plus V1 over 2 plus V1 over 4. Actually, let's combine these two quickly. So 1 minus 2, that's just minus 1. So this one will be minus 1 V1. So let's add these up. 1 plus 0.5 V1 minus V1 over 4. So that's 1.25 V1. Okay, let me just quickly double check. Alright, looks good. Now we have 1 V2, so V2 over 4, so minus 0.25 V2. And then we have minus 30, so minus 30 at the end. Now let's focus on equation 2. So we have, okay, so let's just combine these two quickly. So it will be minus 1 V1 minus 1 V1 over 4, that's minus 0.25 V1. V2 over 4, let's bring this to the other side. So V1 over 4 minus V2 over 4 minus V2 over 16. That's minus 0.3125 V2 plus 3. Alright. Alright, so now let's take this one, and then let's isolate for V1. So let's bring everything to the other side. Actually, let's isolate for V2. It doesn't matter which one you isolate first, but I think isolating for V2 will make it easier. So that means we just bring V2 to the other side. So it'll be 0.25 V2. Divide both sides by 0.25. This and this cancels out. So this gives us 5V1 minus 120 equals V2. Now we can plug that into here. So we have the following: minus 0.25 V1 minus 0.3125, and V2 we plug in 5V1 minus 120 plus 3. Now simplifying this out more, so 0.3125 times 5, that gives me minus 1.5625 V1 minus 0.3125 times minus 120, that gives me 37.5, then plus 3 at the end. Add these two up, minus 0.25 minus 1.5625, that's minus 1.8125 V1 plus 37.5 plus 3, that's 40.5 equals 0. Bring this to the other side. So it will be equal to minus 40.5. The negatives cancel out. Divide both sides by 1.8125. And we get 22.3 volts. And remember, VO is equal to V1. So this is what VO is equal to.